Okay, we have this robot arm ABC, and this arm has a mass of 12 kilogram, and the moment of inertia about its center of mass is uh, 3 kilograms. The center of mass is here, and at the instance shown, length AB has a constant clockwise angular velocity of 2 radian per second. So we have a clockwise angular velocity on length AB, something like this, omega uh, AB, and that's 2 radian per second. Arm BC has a counterclockwise angular velocity of 2 radian per second, so that would be in this direction. This is omega BC. And you're also told that arm BC or length BC has an acceleration of 4 radian per second, and that is clockwise, so that would be in this direction, alpha BC. Okay, uh, there. So we are asked to find the couple and the components of force exerted on arm BC at point B. Right? So there are some internal forces acting on this point. Right? The connection between link AB and link BC. We want to know what those forces are and what is the couple applied to this link BC that causes this acceleration. So that's what we are looking for. Now, we are going to start with kinematics, right? We want to find out what is the acceleration of center of gravity, AG, right? That was the first step that we listed before. So let's do that. To do that, I have to decide where to put my frame. Well, I'm going to put it on point B since I know some information on point B. So I'll put it right there on point B. That would be my X, and this would be my Y, and it's attached to link AB. That's my frame, and it's attached to link AB. Those two decisions I have to make when I want to look at kinematics of a rigid body. Okay, so AG, acceleration of point G, which is the center of gravity, is equal to AB, acceleration of the origin of the local coordinate frame, plus a relative plus alpha cross R plus 2 omega cross V relative plus omega cross R. All right. Well, let me just start from the beginning. So AB, before I cross anything, let's just go over these terms one by one. So acceleration of point B, well, point B is on, this is on link AB. What do I know about link AB? I know its angular velocity, and I know that angular velocity is constant because I'm told that link AB has a constant clockwise angular velocity. So two things I know, angular velocity and angular acceleration is 0. So AB, well, it's an acceleration, and we are following a kind of circular path here. Point B is following a path that is a circular path, and as a result of that, it's going to have a tangential and a normal component. So I'll just write the general form: En plus AB tangential component along tangential direction. Now looking at each term, well, AB tangential is equal to R. Well, that R would be which R? That would be from A to B, right? This is R. This is my fixed axis, and there is a rotation about this. Point B is rotating about this point A, and the R would be the distance from here to here. So that would be RAB omega A B Oh, sorry, this is a tangent, so alpha AB. That would be alpha AB. Now this has constant angular velocity, so alpha is 0, which means this term is 0. Now, a normal component would be RAB omega AB squared. What is the direction? Well, the direction is from this point towards A, and that would be negative x. So that would be minus I. And if you want to plot the vector or draw the vector, well, simply you can just, this would be your vector. If let me be more accurate, if this is my AB, this is A, and this is B, the normal vector is from B to A. Right? That would be my AB N, and this is omega A B. Okay, now next term, A relative, right? The relative acceleration. Well, relative acceleration, we said the way we look at it is that whatever frame, local frame is attached to, assume that it's frozen, it doesn't move, and move the point that you're studying to see how does that movement go. Right? So the frame is attached to link AB. Assume the link AB is fixed now for this to analyze when we're analyzing the relative motion, just for this moment, and see how point G moves. Point G moves on a circular path, again, right? On a curve. Since it's on a curve, again, it's going to have a normal and a tangential component. So there we can write it this way. A relative, right, as a vector, would be A relative in normal direction plus A relative in tangential direction, ET. Well, two components. A relative in tangential direction, let's find that first, would be R, well, whatever is the distance of this point is from the origin of the local frame, that would be RBG, alpha BG, well, alpha BG is alpha BC, so I'm just going to write it alpha BC. That's the alpha of link BC, so I'm going to write alpha BC instead, times, well, I have to find the directions. Now, alpha A relative normal would be R BG, or the distance, omega BC squared. Omega, the angular velocity of that frame, of that link, sorry. Now, looking at the directions, let me start with tangent. Okay, for tangent, if I draw it, let's say there, this is B, this is G, and this is the direction of alpha, right? This is alpha BC. So if that's the direction and that's R, it's perpendicular to R, that would be in this direction. Here is our vector. It's perpendicular to R. Drawing this line there, the horizontal line. We know this angle is 40, this is 90. We can find the other angle. Right? That would be here, that is 40. Or the other one is 60. This becomes, well, sine 40i minus cosine 40j is for tangential component. Now for normal component, well, I'm going to draw it here. Oops, not those. Trying to use. There we go. BG. Put them there. This is B, and this is point G. Now on that, let's put also omega. Well, omega is in this direction. Omega BC. And I have my normal component, right? Normal in this direction. Here goes the vector. If I draw the horizontal line there, this angle is 40 degrees, that we know. So this becomes minus cosine 40i, and sine 40i also negative in negative j direction. Fix this, there you go. These are relative components. The rest, well, let's see what we got there. We have over terms. We found AB. We found A relative. Alpha is 0. Alpha R. Let me find it somewhere there. This term is 0. This term is 0. And this term is also 0. Okay. What we got there?